Dimensional analysis is probably one of the most important skills that I'm going to try to teach you. And the student that can become accomplished in dimensional analysis will have great success in their science classes going forward. So it's something very important to understand and comprehend. Dimensional analysis is basically converting from certain units to other units. And we call it dimensional analysis because we're interested in analyzing the dimensions. The dimensions will tell us how to do the conversion problem. So we're very focused on the actual units or the dimensions. We're more focused on them than we are the actual numbers. Before we get into the strategy on how to do dimensional analysis problems, the first thing we want to talk about are what we call conversion factors. And a lot of these are just factors, conversion factors, that you're just going to have to know or be able to look up to do dimensional analysis problems. For instance, there's many metric conversion factors which you would be expected to know. For instance, 1 kilogram equals 1,000 grams. So the numbers don't look the same, but the units aren't the same either. That's why this is equal. 1 kilogram means 1,000 grams. So these amounts are actually the same thing. So whenever I have something equaling something else, I can write that as a conversion factor. And there's two ways that I write this as a conversion factor. I would write it as 1 kilogram over 1,000 grams. I write these as fractions. I could also write this as 1,000 grams over 1 kilogram. I could write this either way, and the way I'm going to write it, it's going to depend on what I'm converting from and what I'm converting to, which will depend on which way I'm going to write this conversion factor. So it's very important to understand that for every conversion factor you can think of, there's two ways to write it. Another conversion factor, so this was a metric conversion factor, by the way. Everything, the kilogram and grams, both are in the metric units. Sometimes we can have conversion factors that help us to convert between one type of measuring system to another one. For instance, like maybe metric to English. So one that we use a lot is 1 inch. That's in the English system, which we don't use very often. And so if I give you a problem in inches or feet or miles, you'll probably have to convert that to the metric system. And this is the way that we'll do this. We'll do 1 inch equals 2.54 centimeters. So this is a English to metric conversion. A lot of times we call those bridges because we're bridging from one type of system to the next. Bridges are important because bridges I need to look at when I'm trying to determine sig figs in a dimensional analysis problem. But what we're really doing here is we're measuring 1 inch with a metric ruler, and we're showing that 1 inch is equal to 2.54 centimeters. So that 2.54 is actually a measurement. So we would have to think, well, there's 3 sig figs in that measurement. So that'd be important in a problem. You actually have to look at bridges to maybe determine how many sig figs your final answer is going to be. Now in this one, this was a metric definition, really. So this is 1 kilogram is 1,000 grams. It's kind of like a number. So there's no measuring system really here. This is a metric, it's a definition, whereas this one is actually a measurement. 1 inch equals 2.54 centimeters. That would be important. So there's two ways I can write this conversion factor. I could write it as 1 inch over 2.54 centimeters, or I could write it as 2.54 centimeters over 1 inch. I could write it either way depending on how I need to convert it. Okay, so we're just going to jump into, I'm going to do like 4 different problems here, and we're just going to jump right into it and try to see if you can figure out the strategy and how we do conversion factor problems. Okay, so problem number 1, let's say that we have 3.720 meters, and I want to know how many inches that is. Okay, so the way we start this problem, the first time, the way you always start any problem is you write down what the given is. The given was 3.720 meters. So you write down the given, and then we're going to draw a long line underneath this, and we're going to draw some vertical lines. And in the vertical lines, in these spaces, like right in here and here and here, is where we're going to put conversion factors. We're going to put something in the numerator and something in the denominator that are equal to each other. So basically we're multiplying the given by 1, which of course we can do in math. So how do I know what conversion factor I put in here? Well, I need to concentrate on where I am, meters, and where I'm going, inches. And I need to put in a conversion factor here so that I can get rid of the meters unit, because I don't want that unit. And I need to try to go towards the inches unit. So in this first conversion factor, I know automatically, always, I always know exactly what unit I should be putting on the bottom. I should be putting meters on the bottom, because I need that to cancel out. I want that meter unit to cancel out. What unit should I put on the top? Well, I'm going towards inches. So if I happen to know how many inches there are in a meter, I would do inches on the top right now. But I don't. The only thing I know right now is centimeters. I know how many centimeters there are in a meter. Hopefully you do too. There are 100 centimeters in 1 meter. And so I can put this in as a conversion factor. There's 2 ways I can write it: 100 centimeters over 1 meter, or 1 meter over 100 centimeters. Obviously the way I need to write it is this way, so that my meters are in opposite spots and they'll cancel out. So now my units are in centimeters. However, I don't want the unit centimeters, so what should I do with that unit? Well, in my next conversion factor, I should put centimeters on the bottom, and on the top, what unit should I put? Well, I'm trying to get to inches, and I happen to know, because in the last screen, I know how many centimeters there are in an inch, so I'm going to go ahead and put inches here on the top. And the conversion factor I can put in here is that 1 inch is 2.54 centimeters. See, whatever you put on the numerator and the denominator, they're equal. This is equaling 1. This is a conversion factor. And I need to write it this way so that my centimeters will cancel off. And then finally I get to the units that I want to be, and I say, aha, I found you. I want inches. And so I know then that that my problem is going to be done. And all I have to do now is the math. And the way we do the math is we multiply all the top numbers and we divide by all the bottom numbers. So I'm going to take 3.720 times 100 and then divide by 2.54. And when I do that, I get, the calculator would say 146.45669. It give me some big long number. Now and this would be inches. Now I have to figure out how many sig figs should I use. Well, usually the best way to do it is just look at your given. Your given, usually however many sig figs you have in your given, is usually how many you're going to have in your answer. And you'll see that there's 4 sig figs in this one. However, in this particular problem, you need to look at all your conversion factors. And if you have any bridges, you're going to have to use that. So in this problem, we have 1 meter is 100 centimeters. That's a definition. So I don't need to worry about sig figs there at all. But this one, 1 inch is 2.54 centimeters. See, I have measured an inch with a metric ruler, and there's 3 sig figs. This is a bridge because we're going from English to a metric to an English system. So this is a bridge, and there's 3 sig figs there, which means I need 3 sig figs in my answer. So my final answer would actually be 146 inches. So that's the basic way that you do a dimensional analysis problem. You write down the given, right here is the given, and then you multiply by various conversion factors. It might take a whole bunch. You multiply by conversion factors to be able to convert that given into the correct units, and you keep doing this until you have the correct units that you want. And then you'll know that you have solved the problem correctly. I think, so I don't make this a really long video, I think I'm going to stop right there and then do some other videos with like one problem in each video on dimensional analysis problem. It's that important that we understand how to do dimensional analysis problems.